Earth, our home planet. Just a tiny, fragile blue dot floating in this immense cosmic ocean. I mean, really think about it for a second. Every person you have ever known, every human who ever lived, every single story that was ever told, literally all of it happened right here on this rock. Welcome to This Explainer. Today, we're embarking on a truly epic quest. We're going to step off our planet and zoom outward to try and grasp the absolutely staggering scale of our universe. All right, let's dive into this. It kind of begs this deeply humbling question, right? Just how small are we? To truly understand our place in the cosmos, we have to leave Earth's embrace behind and start measuring out the distances. And trust me, the numbers we're about to look at are going to completely change how you view the night sky.
So let's take our first steps out into our own solar neighborhood.
Our very first marker is our closest companion, the Moon. And right out of the gate, we're hit with a staggering number, 160. The Moon sits about 384,000 kilometers away from us. To put that into everyday human terms, if you got into your car right now, pointed it straight up into the sky, and drove at a constant highway speed of 100 kilometers per hour, it would take you 160 days just to reach it. That is more than 5 solid months of non-stop driving. And from that lunar vantage point, looking back, Earth is just this delicate sphere of blues and greens suspended in an ocean of pitch black. Pushing a bit further out, we hit the Sun, which brings us to an absolutely crucial measurement, the astronomical unit, or AU. The Sun is about 150 million kilometers away, and we just call that 1 AU. It basically becomes our standard measuring stick for everything in our solar system. To give you a sense of just how huge that gap is, light, the fastest thing in the universe, traveling at 300,000 kilometers per second, takes about 8 minutes and 20 seconds to reach us. But if you wanted to fly there in a commercial jet at 900 kilometers an hour, it would take you about 19 years. 19 years just to reach the star that keeps us all alive. And this really illustrates the challenge of leaving our immediate orbit. Venturing beyond Earth and the Sun, we set our sights on Mars. Depending on where both of our planets are in their orbits, Mars can be up to 401 million kilometers away. Taking that same commercial jet wouldn't take 19 years this time. It would take upwards of 50 years. This incredibly wild variation in distance is exactly why sending rovers and probes to the Red Planet is fraught with such immense complexities. Okay, moving outward to the very edge of the system. Since even our nearest planetary neighbors are staggeringly far away, we are already pushing our human measurements to their limits. Tracking the journey of sunlight is honestly the best way to wrap our heads around it. We know it takes 8 minutes and 20 seconds for light to hit Earth. But to reach Neptune, that distant ice giant hanging out at the edge of our immediate solar neighborhood, that exact same beam of light has to race across the vacuum of space for 4 hours and 15 minutes. That represents a mind-numbing distance of roughly 4.5 billion kilometers from Earth. But here's the crazy part. Humanity has actually reached out that far. Launched way back in 1977, the Voyager 1 space probe has been traveling for over 4 decades and is now an unbelievable 22 billion kilometers away. It's the farthest human-made object in existence. In 1990, the legendary astronomer Carl Sagan suggested we turn its camera around for one final photograph. From 6 billion kilometers away, Earth was just this tiny, faint pixel. Sagan poetically called it a pale blue dot, reminding us that we really are just a small speck in the immense universe. So where does our solar system actually call it quits? That would be the heliopause. Out at the very fringes, past a theoretical sphere of icy objects called the Oort cloud, which extends up to 100,000 astronomical units, by the way, scientists define the true boundary of our system. The heliopause is where the sun's solar wind is finally stopped cold by the interstellar medium. This is the exact threshold where our sun's influence completely ceases and the vast, silent realm of true interstellar space begins. Now we are heading out into the Milky Way. Having crossed that boundary, we literally have to throw away our old measuring sticks. Our next stop is the closest star system to our sun, Alpha Centauri. It sits 41.3 trillion kilometers away. That is over 276,000 AUs. At this colossal scale, the astronomical unit loses all practicality. It'd be like trying to measure the Pacific Ocean with a classroom ruler. So, astronomers adopt the light year, the distance light can travel in one entire year. Using that, Alpha Centauri is roughly 4.4 light years away. Just to help you understand how empty space really is between these stars, consider this massive number, 70,000. If we wanted to visit that closest stellar neighbor using our current technology, let's say we hop on that Voyager spacecraft traveling at a blisteringly fast 17 kilometers per second, it would take over 70,000 years to reach Alpha Centauri. This colossal gulf between stars just completely underscores the unfathomable challenge of interstellar travel.
And yet, all of those stars we've just discussed, they're barely a fraction of our home galaxy. This comparison is truly eye-opening. The Milky Way spans about 100,000 light-years in diameter, packing in hundreds of billions of stars. But human influence? It is confined to a tiny microscopic sphere called the human radio bubble, extending just 100 light-years from Earth. That is the absolute furthest our radio and television broadcasts have ever traveled. Beyond that tiny bubble, it is as if humanity never existed. Our entire recorded history is just a tiny whisper, completely undetectable to the vast majority of our own galaxy. Let's pull the camera back even further to the grand cosmic web.
If your mind isn't stretched enough yet, brace yourself, because we are leaving the Milky Way entirely and entering intergalactic space. Out here in this silent wilderness, entire galaxies float around like tiny islands in a cosmic ocean. Our Milky Way is part of what's called the local group, a neighborhood of over 50 galaxies spanning 10 million light-years. But zoom out again, and our local group is just a tiny speck within the colossal Virgo supercluster. This titanic structure encompasses a region 110 million light-years across and holds thousands of galaxies. Space at this level absolutely dwarfs literally everything we've talked about so far.
And you guessed it, it doesn't stop there. Journeying outward from Virgo, we arrive at Laniakea, which beautifully translates to immense heaven in Hawaiian. This is our grand galactic home on a truly incomprehensible scale. Extending over 500 million light-years, it contains the mass of 100 million billion suns. It's this breathtaking gravitational masterpiece, bound together in a cosmic web of motion, all seemingly drawn toward a mysterious region at its heart known as the Great Attractor. Our Milky Way, our local group, our entire human history, we are just one microscopic component of this gigantic swirling structure.
Finally, we reach the edge of the observable universe.
We have officially arrived at the absolute limits of what human science can perceive. Think of it like a massive cosmic nesting doll. We started in our solar system, zoomed out to the Milky Way, stepped back to the local group, pulled way out to the Virgo supercluster, stepped back again to the magnificent Laniakea, until we finally hit the edges of the observable universe. We're looking at a staggering sphere measuring about 93 billion light-years in diameter. It is the absolute hard limit of what we can physically see.
But this actually brings up a fascinating scientific riddle known as the cosmic expansion paradox. If the universe was born in the Big Bang roughly 13.8 billion years ago, how on earth can the observable universe be 93 billion light-years wide? Shouldn't it only be 13.8 billion light-years in any given direction? Well, the answer is that space itself is expanding. Ever since the Big Bang, the universe has been stretching out like a rubber band, actively increasing the physical distance between all these celestial bodies. Which inevitably leads us to the biggest, most mind-bending question of all: what lies beyond the observable universe? This remains one of the absolute greatest mysteries in all of cosmology. Because space itself is expanding, there are regions of the cosmos that are currently expanding away from us faster than the speed of light. That means the light from the galaxies in those regions will never ever reach our telescopes. They are just retreating endlessly into the dark. It leaves us with this deeply humbling realization that there are infinite regions of space, entirely undiscovered galaxies, and cosmic wonders that we will simply never get to witness. So as we stand here on our tiny pale blue dot, I leave you with this. Knowing how unbelievably vast the unknown truly is, what other magnificent secrets do you think the universe is hiding from us out there in the dark?